Welcome to the next unit of PreCal. So what we're going to be doing today is taking our inverse trig functions that we did last unit and take it a little bit further. And that's what we always do when we're talking about PreCal. So when we talk about inverse functions, I want you to think about your rainbow. So our side rainbow here is sine inverse, cosecant inverse, or tan inverse. And then our top rainbow are cosine inverse, secant inverse, and cotangent inverse. So we're going to use that and not talk about the unit circle, but talk about triangles in the coordinate plane. So it is going to be important which trig function we're talking about and where we put that triangle. All right, so let's look at number one. So remember that when we're doing inverse trig, we're always finding an angle measure. Well, in this case, since 3/5 is not on my unit circle, I cannot find an exact angle measure for that. I can type it into the calculator and get an approximate angle, but I don't know what exactly it is. So in this case, I'm just going to put theta. Just give it a symbol or symbol and kind of figure out what we can do from there. So sine inverse of 3/5 is going to find an angle measure. Since we're doing sine inverse, that's our side rainbow. And since it's positive, means that I have a triangle in quadrant 1. So this is where my angle is going to be. Well, since we're doing sine, 3 is our opposite side, and 5 is my hypotenuse. I could honestly say this is 3/5 and this is 1, but it's easier to do this because then I can do Pythagorean theorem or know your triples and figure out what this side length is, which is 4. So then the question is, since I figured out what this angle measure is what is tangent of that angle? Well, tangent is opposite over adjacent, so 3/4. So my final answer would be 3/4. I could have done this on the unit circle, giving you like root 3 over 2, and then find out what angle measure gives you root 3 over 2, like same kind of situation like that. But in this case, we asked you for what angle gives us sine inverse of 3/5, which is this angle here, which I don't have to find out what the measure is, because all I'm going to do is figure out what tangent of that angle is, which is 3/4. So let's look at number 2. This arctan of negative 3/4, this thing inside of here, since it's asking for arctan, is just asking for the angle. Arc and inverse are the exact same question. I could have put tan to the little negative 1 or tan inverse of negative 3/4 and get the exact same thing. So since tangent is our side rainbow and it's negative, our triangle is going to be in quadrant 4. So this is where theta is going to be. So tangent is either y over x or opposite over adjacent. So this is 3 and this is 4. But one of them has to be negative. Well, if you go to the right, then that's positive. If you go down, that's negative. And then again, you know your triples or do Pythagorean theorem and end up getting that that's 5. So this arctan of negative 3/4 gives us this angle measure. Could put it in the calculator, get an approximate thing. But really the question is, what is cosine of that angle? Well, cosine is the adjacent side over the hypotenuse, so 4/5. So be careful with your negative signs, just like what we did back in Unit 1. What about 1/2? I could draw a triangle where the opposite side is 1 and the hypotenuse is 2, but this is a unit circle value. 3/4 and 3/5 are not on the unit circle, but 1/2 actually is. So if I ask you what is sine inverse of 1/2, you should be able to tell me that's pi over 6. That's the angle in which our y value is 1/2. Again, using our side rainbow, positive values are in quadrant 1, so pi over 6. So then the question is, what is sine of pi over 6? Well, that goes back to 1/2. This doesn't always happen for every single question. It might change the sign in which your inverses are different and all that. So they don't just cancel each other off. In this case, they do, but not in all cases. So don't just see sine inverse and cancel it off, because that doesn't always happen. Go through the steps. Sine inverse of 1/2 is pi over 6. What is sine of pi over 6? 1/2. So let's look at this next one. So we're going to do sine inverse. Again, that finds me an angle measure. And since it's sine inverse and it's negative, our triangle is in quadrant 4, where here's theta. So our opposite side is 3, our hypotenuse is 5. The hypotenuse is never negative, and we're also going down here, so that's negative 3/5. And then this ends up being 4. So what is tangent of that angle of the triangle that we got here? Well, it's opposite over adjacent, so negative 3/4. Again, negative 3/5 is not on the unit circle, so I can't just figure out a unit circle value. I need to draw a triangle. What about cotangent inverse of negative 15/8? Well, cotangent is the top rainbow, and since it's negative, our triangle is going to be in quadrant 2. So this is where that angle that we get from doing cotangent inverse of negative 15/8. So cotangent is a reciprocal of tangent. So tangent's TOA, so opposite over adjacent. So this is adjacent over opposite for x over y. But then one of these has to be negative. You're going up here, so that has to stay positive, and this is going to the left, so that's negative. So what is cosine of that angle? Well, I need the hypotenuse. This is a triple, 8, 15, 17. So the adjacent side over the hypotenuse is negative 15/17. Secant inverse. Secant is the top rainbow. So I'm going to draw a triangle here. It gives me this angle measure. You don't have to draw that every single time, but just helpful for notes that this is giving me an angle measure, but I don't need to know exactly what it is. So secant is a reciprocal of cosine, so I can think about this as the hypotenuse and this as the adjacent side. So since we're going to the left, that's negative 3. The hypotenuse is always positive, and then the adjacent side would be 4, or the opposite side would be 4. So what is sine of that angle? What's the opposite side? 4 over the hypotenuse, 5. And again, leave your answers exact. Leave them in fraction form, but just easier. You don't have to take it any step further. This is not 0.75. It is just 4/5. Ooh, what about arc secant of negative 6? Well, it is helpful to realize that that's negative 6 over 1. And then also that this gives me an angle measure. So since we're talking about secant, secant is a top rainbow. Since it's negative, it's in quadrant 2. If it was positive, it would always be in quadrant 1. So we put some negative ones on here. So same thing like the last problem, I can treat this as the hypotenuse and this is the adjacent side. The hypotenuse is never negative and the adjacent side is going to the left, so that's negative 1. So is this a triple? No, it's not. So you have to do some Pythagorean theorem. So it doesn't matter what this is, I'll just call it y since it's going up, plus negative 1 squared equals 6 squared. So you get y squared equal, or plus 1, I'll do all my steps, equals 36. So y squared equals 35. So we square root that. Does it simplify? No. So this is root 35. So then the question is, what is cosecant of this angle measure? Well, cosecant is the reciprocal of sine. So sine would have been root 35 over 6 because this is where my angle is. But in this case, it's 6 over root 35, which we can't have, so 6 root 35 over 35. That's something easy you can do, you can rationalize the denominator with. If it was something more complicated, like what we might see here in a bit, then you don't have to rationalize. But in this case, it's pretty simple, straightforward, so you could definitely do it that way. All right, so secant of tan inverse of 3x. So again, this inverse always tells me an angle measure. No matter what is inside of it, what it is, like it, as long as it's inverse or arc, you find an angle measure. So since we're dealing with tangent inverse, that's the side rainbow, and we're assuming x is positive, that's safe to assume that this ends up being positive 3x. So that's in quadrant 1. Anytime you're given inverse or arc of any positive value, it's automatically in quadrant 1. Well, tangent, you can think about as y over x, or opposite over adjacent of this angle here. It would be 3x over, well, everything is divisible by 1, so this is 1. So then we have to do some Pythagorean theorem to figure out what my radius is or my hypotenuse. So I'll just put r squared, since we're in pre-cal and that's now our radius. And then do 1 squared plus 3x squared. So this is where a couple people have problems with, because what they do is that they square the 3 or square the x really, and that's it. So they put 3x squared. But it's actually supposed to be 9x squared. And when you square root that, that ends up being your hypotenuse. You could put 9x squared plus 1 inside, that doesn't matter. But if it was subtraction, that order does matter. In this case, it doesn't. So what is secant of that angle? Well, secant is a reciprocal of cosine. Cosine is 1 over that. So that means it's square root of 1 plus 9x squared over 1, which I don't need the over 1. So that's my answer. You could put over 1 if you want to, but who needs it? All right, what about this next one? Well, cotangent, arc cotangent tells me an angle measure. And it's positive, so it's going to automatically be in quadrant 1. Well, cotangent is, you could think about it as x over y. So this is 1, this is x. And if you do all the Pythagorean theorem again, just like what we did over here, we end up getting 1 plus x squared, or x squared plus 1. Well, what's nice is that in this problem, you didn't really need that hypotenuse because we're just going back to tangent, which is the opposite over the adjacent. So just x over 1, or simply just x. So draw the triangle out. It's very helpful. Do Pythagorean theorem. It is very helpful on practicing what you need to do for this unit. Now, this is where I get a lot of students that are trying to draw triangles. Tangent is not asking for an angle measure. Tangent is asking for what is the y over x at 3 pi over 4. Tangent of 3 pi over 4, that's a unit circle question. Okay, this is on the unit circle. And it's asking for what is y over x at 3 pi over 4. Well, 3 pi over 4, it's root 2 over 2, negative root 2 over 2. So if you divide that, you end up getting negative 1. So tangent of 3 pi over 4 is negative 1. It is not a triangle in the coordinate plane. It is just a unit circle question. So since we figured out the inside, now we can figure out what is arc cosine at negative 1. So this is asking you, what is the angle? What angle gives us the next value at negative 1? Well, next value of negative 1 goes to the left one, and that ends up being pi. So remember, in this class, if you're doing arc or inverses, just you leave it in radians. Don't change it to degrees. Don't tell me it's 180 degrees. Leave it in radians. Number 11 is another unit circle question, 4 pi over 3, and it's cosine of that. So it's just asking what is x at 4 pi over 3. This is a question where some people are just going to try to cross this out and just leave me as 4 pi over 3 as an answer. And that's not going to happen here. So 4 pi over 3, again, is a unit circle angle, and I'm looking for the x value there. Well, what x value is at 4 pi over 3? Well, that's negative 1/2, because you're going to the left and down, so it's the point negative 1/2, negative root 3 over 2. So cosine at 4 pi over 3 is negative 1/2. Then the question is, what is cosine inverse of negative 1/2? Now, cosine inverse deals with the top rainbow. 4 pi over 3 is in quadrant 3. If I'm doing cosine inverse, my angle needs to be over here in quadrant 2. And where is cosine negative 1/2 in quadrant 2? Well, 2 pi over 3. So understand that these cosines don't cancel off and you're left with 4 pi over 3. Your full answer that you're supposed to get for this is 2 pi over 3 based on our rainbow values. All right, last but not least, let's look at this one here. So again, this is just cosine of negative 2 pi over 3. This is asking what is the x value at negative 2 pi over 3. Well, negative 2 pi over 3 is really the same thing as 4 pi over 3. It's in quadrant 3, just 2 pi over 3 to the clockwise. So quadrant 3. So cosine at negative 2 pi over 3 is just negative a half. That's what the inside is. Then we're asking what angle gives us arc sine as negative a half. Well, arc sine or sine inverse are the side rainbow. And since it's a negative 1/2, it's down here. So where down there is our y value negative a half? Well, negative pi over 6. Not 11 pi over 6, but a negative 11 pi over 6 because our range has to be from negative a half to a positive a half. So these are inverse trig functions, sometimes on the unit circle, sometimes not. So you have to be able to decipher which one's which. So with these types of problems, you need to be very careful on knowing your unit circle question or unit circle exact values. Okay. In number 11, we had the same denominator. In number 12, we did not. We both had cosine here and we switched from sine to cosine here. So pay attention to what you're doing. Pay attention to when you draw triangles in the coordinate plane and when you don't. If you have any questions, comment in tutorials or ask in class. See ya.